In this class we're going to talk about jump statements. There are three jump statements in Java. First one is break. I have briefly introduced break. The second one is continue, and the third one is return. So there are three break statements in Java. However, additional ways of changing the flow of program in Java provided in exception handling, a method that gives us a structured method or a structured way to trap and even handle runtime errors in our programs. So exception handling is actually supported by Java and supported by 5 keywords: the try keyword, catch keyword, throw keyword, throws keyword, and finally as keywords. I'm going to talk about exceptional handling much later. So let's talk about the three jump statements, that is the break, the continue, and the return. And we're going to start with the break. The break statement has three major uses. So of essence to know, the break statement has got three major uses. So let me put a comment here and say break statement. So it has three major uses, and the first one is it terminates a statement sequence in a switch statement. We have seen the break statement in a switch statement. That is the first use of break statement. Number two, we can use the break statement to exit a loop. We've used this with the enhanced for loop. And number three, we can use a break statement as a civilized form of go to. So let's look at how do we use a break statement to exit a loop. Now let's have an example of a loop. It's for, I've shown you this before, but let me just repeat it. Int I go to 0. Let's say I is less than 100, and let's increment I. So I plus plus. Let's have our curly braces, and our curly braces we want to check if I is equal to 10. We want the loop to break there, to exit when I is 10. So break. So if when we get to a point where I is equal to 10, the loop is going to exit there, or is going to terminate there. Okay. We can print after this loop. Let's print a loop completed. System.out.println. Yeah, let's print loop completed. So I want you to notice the use of break right here. Notice the use of break right here, this word. So we are going to count from 0 to 100, but by the time we get to 10, where I is going to be 10, then we want to exit the loop at that time. Now if you run this code, let's check the output here. Loop completed. That's what it tells us. Loop completed. It tells us loop completed because you're not printing anything here. Okay, let's print I. System.out.println. Let's print I. Yeah, let's print I so that we see the counting. We print the value of I. Now I remember we said when a loop is exited, the next line after the loop is executed. So once this loop is exited, we expect that this line should be executed. So the value of I here will be printed a number of times, and then once this loop is exited, this is going to actually be printed. That is going to be printed. So let's run this code again, and Let's check the output. Boom, you can see now 0 1 2 3 4 5 6 7 8 9, then loop completed. So by the time I gets to 10, the loop terminates, and then the next line is run. So when break is encountered inside a loop, the loop terminates and the control of the program resumes at the next statement that follows the loop. Now it's important for us to know that break can be used with any of the Java loops to terminate them. So we can terminate any of the Java loops with a break statement. When you use a break statement in a nested loop, termination will happen only in the inner loop. For instance, let's have a nested loop. So for, let's say int I is equal to 0, let's give it 0, and let's say I is less than 3, and I plus plus, increment it. Let's have our curly braces. This is the outer loop. Then I want us to print system.out.println. I want us to print the words pass, and then we add we have also the value of I. We pass the value of I, and let's have an empty space there of, okay, here we need to have plus. So that is our outer loop. That is what it does. Let's have our inner loop here. We say for int j is equal to 0. Say j is less than 100, and let's say j plus plus, and then let's have curly braces. Then let's have the curly braces, and then let's print j. System.out.println. We are printing j and some empty space. Yes. Now outside the inner loop, this is our inner loop. So outside the inner loop, let's just print an empty line. Say system.out.println, just printing an empty line. Then this is the outer loop. So outside the outer loop, now we can say the loop is completed. So system.out.println, and here we say loop completed. Say loop completed out here. So we want to break here. We have in the inner loop here, before we print j, we want to break when j is actually 10. So if j is equal to 10, you want to break there. So this is the concept that I'm trying to drive here, that when we use a break statement inside in nested loops, the break will only apply to the inner loop. Now this is our inner loop here, so the break is inside this loop. It means now when the value of j is 10, this loop will be exited. When this loop is exited or terminated, this main loop won't terminate. This main loop will continue to run. So if we run this code, we check our output here, you see it has pass 0. Now pass 0 is from this line here, system.out.println pass, then plus I. At this point I is 0. Okay, then here we are printing j. I want you to realize we are printing j's. So the first round j is actually 0. We are printing 0, then j goes to 1 all that way up to j is equal to 9. By the time j gets to 10, I want you to notice something. By the time here j gets to 10, this loop is exited, so an empty line is actually printed, and then this loop ends. Okay, we can put something here and say this line is printed after j is 10. Okay, or when j is 10, it's printed when j is 10. Now if you run this code again, let's check the output here. Now you can see, so when j is 10, we exit out of the inner loop and we still run the outer loop that prints this line is printed after j is 10. Then once this outer loop is run, if we don't have any other code in this outer loop, then the line that follows the external loop is executed. Now that is how we can use break as to exit a loop, and we said we can use the break statement to exit any form of a loop as in Java. Now we can use also break as a form of go to. Can use break as a form of go to. Let's just look at an example, or let's write an example code for better understanding. How do we use break as a form of go to? So let's declare a boolean variable. So say boolean t, and we assign it the value of true. Assigning it the value of true. Then let's say first, I'm going to explain what I'm doing. Then let's have curly braces following first. Then we say second, we have that. Then we have curly braces for the second block again. Then we can have third and full colon, then curly braces for the third block again. So inside the third block, I want us to print system.out.println. Let's say before the break. In other words, this statement needs to be printed before the break. Then again, still inside here, I want us to print a line that will not execute. Say system.out.println. we say this won't execute. This won't execute. Then outside this block, this is actually the third, the inner block. So when we get out of the inner block, it means now we are actually in the second block. So let's print something. System.out.println. So let's say come here. Say come here. That's the statement. Remember that print statement is actually in the second block. Then outside the second block, of course, we are entering the third block. Okay, outside the second block, we are entering the third block. So I want us to just say system.out.println. we say this is after the second block. This is after the second block. This is after the second block. Just want you to see something. This is after the second block. Okay, now I want you to notice something here, that the general form of of using the break statement as a form of go to is that we have a break label. The break label is going to identify a block of code. Okay, the break label is going to identify a block of code. So execution of the form is going to transfer control to the named block. Okay, and of course a label in Java is any valid Java identifier that is actually followed by a full colon. So this is a block of code, and we have given it the label first. This is another block that we've given it the label second. This is another block that we've given it the label third. So I want you to notice something here, that we have I want us to introduce a break statement after this. So we say if t simply means if true, because t is true. So if t, I'm saying break second. if t break second. Now this statement simply means if true, break out of the second block. Break the second block. That's what I mean. Let's see how this behaves so that you can get a good understanding. So if we run that and we check the output here, before the break is executed, okay, then we have this is after the second block is also executed. So let's come to our code. I want us to understand the code. So the first thing before the break, this one is executed, it is in the third block. Now if t, when we check t is true, so this will return true. If this returns true, break second means don't run the third, so this won't execute, don't run the third. Okay, then we go to the second block, which is this is the second block here. We are supposed to actually terminate the second block. So you see, because we are terminating the second block, this other line won't run, the second block won't execute, so this other line will not run, and it will come and print this line that is in the third block. So we can actually use this to say, move from this one, go to that one, move from this block, go to that block. Right now we are moving from the third block. We are moving from the third block, we are going to the first block by making sure that we are breaking the second block. Okay, but if we say here, if we say break first, you won't see anything. Let's just do that. Break first. We want to break the first block. Let's run this code. Now let's check the output. What do you see? Before the break only. Why? Because it will run this code. Now here, if t break first, it means now it is true, so it is going to break the third. But remember also, the first is holding, all these are held inside the first block. So all these other code after this one is run, all these other code won't run. It will run the code that is actually outside the block. So that is how we can use the break statement to move from one part or to go to a specific block, that is if we want to. Now the second jump statement is the continue. Now at times you want to continue running the loop but stop processing the remainder code in its body for maybe a particular iteration. So we have the continue statement that performs such an action. So if you look at the while and do while loops, a continue statement will cause control to be transferred directly to the conditional expression that is going to control the loop. But in a for loop, the control is going to the goes first to the iteration portion of the for statement, and then to the conditional expression. So I want just us to look at this. Explaining without code might make things harder for you. So let's look at this example, the for loop. So you have for, and we say int I, let's give it 0, give that a 0, then we say I is less than 0 again, then we increment I. So we increment I, then let's have our curly braces out here that way. So let's print system.out.println, and what I want us to print here is basically I. Let's print I. Okay, let's print I basically, and then I want to say if I modulus 2 is giving us 0. Of course you know what I mean. That is we are testing for an even number. If I modulus 2 gives 0, then continue. We say continue. Okay, then let's come here and say system.out.println. Let me just print an empty line. Yeah, just like that. Okay, I want you to pay attention to I modulus 2 is actually checking for even numbers, because if you divide a number by 2 and you get 0, it means that number is even. You need to pay attention to that. Okay. Now if you look at this code, let's just run so that we see how the code behaves. Then I explain the code. So we check the output. Now there is nothing printed. I'm gonna tell you why. Now continue is going to specify a label to actually describe which enclosing loop to continue. Now if you look at this, int I is equal to 0, I is less than 0. Already this condition is returning false. Okay, because we have specified it to 0. I is less than 0, then we are incrementing I. Okay, so let's change this one to something like I is less than 3. I is less than 3, then let's increment I. So system.out.println. So here what happens is 0 is actually less than 3, so it is going to print I. If we run this, let's run this other version. Let's just run this, check. It's printing 0 1, then an empty line, then 2. 0 1, an empty line, then 2. Now pay attention. So for the first round, the first iteration, I is actually 0 and 0 is less than 3, so it is going to print I. So it prints 0, and then it increments 0 to 2. But here it checks this condition. If if 0 divided by 2 is equal to 0, continue. But 0 divided by 2, 0, what is 0 divided by 2? What is 0 divided by 2? Is 0, right? Okay. So I'm not really sure about that. It continues. So we continue. Then the second round, now I has become 1. So if I modulus 2 is 0, continue. What does it mean? It simply means here we are going to repeat this round here. We are going to go, so if as long as we find that this one is not returning true, as long as this one is not returning true, we are going to come to the beginning of the loop. That is why you see 0 and 1 printed. Then we come to where I is 2. So 2 divided by 2, it gives us a remainder of 0. So it is true. So continue. Now continue means do not start do not start another iteration, so it will come and run this when actually I is 2. It will come and run this. That is why you see an empty line printed here. Okay, here. Now after that, after it has run this, of course, now we have I as 2. You have I as 2, then it goes back now to the beginning of the loop. So in other words, if this condition is met, this code here, the empty line is only printed when this condition is met. Now if we change this to something like 5, so that we can have 2 and 4 as even numbers, I want you to see something. Let's run this code. Yeah, let's check the output. Now you have 0 1 empty space 2 3, 0 1 empty space 2 3. Understand? So the first time this is 0, so it runs, then it checks this one doesn't qualify because it doesn't return true. It prints 0, then goes there. Now it's 1, it doesn't return to true. It prints 1 and goes back there. Now I is 2. When it comes, checks this one is true, so it's going to print this empty line again. Get me right? It's going to print that empty line. Then I is actually now 3, so checks 3. Checks 3. This doesn't pass, so it's going to print 3. Did you check here? It's going to print 3. Okay. And then 4. Actually, this passes, so it's going to print this one again. Yeah. So that's how we actually use continue. We can also use continue to specify maybe a label so that you can describe which enclosing loop to continue to. We have used labels with break. We can still use labels with continue. Let me show you an example code. For instance, we say something like we specify a label outer, then followed by curly braces as I have shown you, and then inside this or rather after this outer, let's give a for loop right after this. So we say for, and then let's have the condition. Let me just show you something. And here we say int I is equal to 0. Int I is equal to 0. Then we say I is actually less than 0. Then we say we increment I. So we say I plus plus. It's so important that we understand that. So we have that label. So that is the outer block of code, and then we can have an inner block of code for, we say int j is equal to 0, then we say j is actually less than 10, then we increment j. Is now an inner block of code. So let's have an if statement. So if we want to actually continue to the outer block of code, if j is going to be greater than I. So if j is greater than I, then let's do something. Let's go to, I want us to move to the outer. So then continue outer. Then we can come outside of this, and we print say system.out.println, and here we basically want to print j times I, something like that, or I times j, whatever, I multiplied by j. That is what we want to print. Okay, want to print I multiplied by j. Then outside here, outside of all these loops, now we can print an empty line. So system.out.println, let's just print an empty line. So I want you to see what is really happening in this piece of code, because it's essential. Okay, so if you look at the continue statement here, it terminates the loop counting j and then continues with the next iteration of the loop counting I. So you can see here we have this loop that is actually counting j. So when you get j as greater than 1, it is going to terminate this loop. But even after terminating this loop, it is going to this other loop, this outer loop is going to continue. In other words, when we say continue outer, means terminate this current loop and run the loop with the label outer. So if we run this code again, let's run this code. We check the output. Now you see there's nothing. Why is there nothing? Okay, let's make this less than, at least we get some truthy things before we make that less than 3. Now you come here, there is 1024. So see, first round we are looping around I is 0, yeah, so I is actually 0. So the first round we come in here, then if you look at I as 0 and j is 0, so j this continue, this if statement returns to false, so we won't continue. We are going to print 0 times 0. That gives us what? Let's come back here. We have actually wait, in j I is okay. So the first one is actually going to give us, since j is greater than 0, this is actually false. So it's going to give us, first one is printing 1, then the second round. Now by the time we get to where j is where j is greater than 1, then we are going to move to the outer block, and the outer block here, we are talking of this 2. Now let's see, the outer block here is going to we are going to move here in a second round. So we are exiting this one, we are exiting the inner block, we are exiting this inner block here, but so this iteration of j will stop, but the iteration of I here will continue. Basically the iteration of I will continue. Okay, so we have the continue statements terminating the loop counting j and continues with the next iteration of the loop counting I. So Java provides a rich set of loop statements which fit most applications. Thus there are actually rare good uses of continue. However, we can have special purposes in which early iteration is needed. So the continue will actually accomplish such a scenario. Let's move to the last jump statement before I introduce you to classes. It is return. The return statement. Allow me to clear this. Alright, I'm gonna clear that. So the return is explicitly used to return from a method. That is, it causes a program or the program control to transfer back to the caller of the method. But we are going to have a full discussion about the return later after we have discussed methods. So the return statements can be used to cause execution to branch back to the caller of the method at any time in a method, because of this because of the return, the statement will immediately terminate the method in which it is executed. So I'm going to discuss in details about this. In the meantime, let's just write an example so that you see what is happening. So I'm declaring a boolean variable j. I'm giving it the value of true. Then I'm printing system.out.println. I am printing the words before the return. It's printing the words before the return. Okay, before we actually come to the return, before we meet the return. Okay, then let me have an if statement. So if j, that means if true, then return. Okay, return. So that means return to the caller. Then let's say system.out.println. Just say this code won't execute. This code will not execute. So just to show you what is happening. Now this is what is happening. Boolean j is equal to true. So if j, return. Now since we say j is equal to true, this statement is not going to actually execute because it is going to return to the caller of the method. So let's just run this. We check the output. So before the return, this is the only statement that is running before the return. Why? Because here it's true. This condition returns true. Now okay, let's change this to false. Now let's run this one. Now you see there's literally there's literally nothing printed now. Okay, so basically what is happening here is we can use the return to return from a method. Now so as soon as in this program, as soon as return executes, the control is passed back to the caller. Thus we don't have this last statement executing. The last statement is not going to execute. So the if statement here, this one, the if statement in this example is actually necessary, because without it the compiler is going to flag an unreachable code error, because it would know that the last print statement would never be executed. So the if j statement here is, I have put it intentionally to actually trick the compiler just for our demonstration purposes, yeah, to make sure that we are not going to be flagged into that error. So that's all about the jump statements. For the return, we are going to have classes to deal with it much later. See you in the next one.